This video is for question 7 of F322 paper January 13. Here you've got compound D, which is going to react by two mechanisms that we know: nucleophilic substitution and electrophilic addition. It's given you two molecules to react with two different functional groups on this molecule: potassium hydroxide and hydrogen bromide. Which functional group on that molecule will the hydrogen bromide react with? Pause. Yeah, the hydrogen bromide is going to react here with our alkene. The potassium hydroxide will react with the chlorine atom here. I'm going to start with nucleophilic substitution, so reacting with potassium hydroxide. But before I do, to make it easier to write the equations for myself, because that's what the bullet points, you've got to go through these bullet points when you answer. You want an equation, the structure of each organic product, the mechanism, and the type of bond fission. So to start off with, first of all, I'm going to convert this into structural formula to make it quicker for me. So I've got CH2, which is my first part of the molecule. Then I've got a CH, then another CH2, then I've got another CH2 connected to a chlorine, so CH2Cl. So that's what I'll start using in my equation, and it will just make it easier. I will actually draw out the full structure, obviously, when I do the mechanism. For your mark for the structure of each organic product, it is okay to draw the structural formula. It may be easier for you to draw a displayed formula. What you cannot use is a molecular formula. So, moving on then to actually answer this question. For nucleophilic substitution, I am going to react, first of all, my CH2, CH2, CH2Cl plus potassium hydroxide, and that will give me CH2, 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 and it's a substitution, so the Cl has been replaced by the OH plus potassium chloride. So that will give me a mark for the equation. I'm just checking I've got the right number of CH and CH2s. 1, 2, 3, 4. Yep. That will give me a mark for the equation, and it would also give me a mark for the structure, since I've used the structural formula. You can do this equation in displayed formula. It's just going to be quicker for me here to write it out like that. It's messy enough as it is. So then, to draw the mechanism, again here when I draw the mechanism, I'm not interested in the part of the molecule at this point that has the CC double bond, so I'm still going to draw that in structural formula as CH2CH. Then there's another CH2, and then you have CH and your Cl bond. Now I made that bond a little bit longer because I want to be able to show my mechanism clearly. So I'm going to get a mark for putting my dipoles on. Chlorine is more electronegative, so chlorine will have delta minus, and the carbon will have a delta plus. I've got to have my attacking nucleophile, which is going to donate a pair of electrons to the carbon. Here is my OH minus. I'll put my lone pair on. Now this OH is forming a bond, so movement of a pair of electrons via the curly arrow to the carbon, with a nice big arrow there, clearly going to the carbon. Then my second arrow from the bond, make sure it's from the bond, breaking the bond, and the electrons going to the chlorine. That then goes on to give my product, which is the same CH2, CH, CH2, CH, H, now OH, and very importantly, plus the Cl minus with its lone pair. So that there is the mechanism. You will get 1 mark for the equation, 1 mark for the structure, 1 mark for the dipoles, 1 mark for the correct curly arrows, and 1 mark for putting in that Cl minus. So there you've got 5 marks altogether. The mark scheme will allow you to have the structure shown here or there, or you might even want to draw it out separately to be sure. But this mark scheme would have allowed it to be seen anywhere, and that is generally the case on all mark schemes. Last little bit that we need to say about this is what kind of bond fission it is. Here we have, pause, yep, heterolytic bond fission. So let's just scribble that in there. Heterolytic bond fission. Let's get that R looking like an R. Remember, it could be, it's not in this question, quality of written communication, but there could be, so let's make sure we're spelling these things correctly. So that's my first mechanism for nucleophilic substitution. Let's go on now to try the mechanism for electrophilic addition. So here we are going to be doing electrophilic addition. Make sure that's spelled correctly as well. It's not, the pencil's not on this question, but it could be. Remember, you're not getting any marks for stating that as it's stated it in the question. But here then, I'm going to draw out my molecule slightly differently this time to ensure that I have this double bond clearly displayed, because that's the key thing in this one. So I've got CH, and it draws it out, CH, H, and then I've got CH2, Cl. Now, here I'm taking my original compound D again. It could be that you use your compound now converted to an alcohol with your OH. That's absolutely fine. I'm just taking it from the original compound. So, writing my equation then, I've got plus HBr, and that will give me, and you've got to be careful with this one, it's going to give me potentially, or in fact, 2 different products depending on where the H and the Br join the molecule. So we've got CH3 with the H joining this carbon, CH Br, CH2, CH2 Cl, or CH2 Br, this time it's the bromine that's joined onto this carbon, CH2, CH2, I need another CH2 Cl. So you've got 2 different structures, and this is what people often forget, and you'll get an extra mark for that second structure. So that's my equation. Notice I only have one product because it's an addition reaction. Now I need to draw the mechanism. So make myself a bit more space. Mechanism again, the all important part is the C double bond C in electrophilic addition. So I've got my H's here, H off there, and this time I'm going to shorten this even more, CH2, CH2, Cl. I'm not interested in this part of the molecule, but I do have to copy it accurately each time I'm working. Now, this is approached by my hydrogen bromide. It is here. The dipoles on this, I've got a delta plus and a delta minus, bromine being more electronegative. My collection of negative charge is here in the double bond, that double bond being made up of a sigma and a pi bond. I've got my first curly arrow to the H from the double bond, then this bond must break. Remember, we've got to state the bond fission here again, which is again heterolytic fission, exactly the same as it was for the other mechanism. So that's the first part of this mechanism. Then this goes to, and I need to draw now my carbocation. Here I'm putting my H on this first C, this new bond from the H is on my first C. So in fact that should be my green H there. Put that in green. That's my green H. Now I've got just a single bond here, a C with one H on it. And this of course now, because its bond has been broken, is a positive charge. Make sure you show that positive charge clearly. It's a full positive. Then we have the rest of the molecule along there, CH2, and it's important that you put that in, otherwise you'll lose a mark for your intermediate. The rest of that molecule, and now you've got your bromine that's still got to bond, Br minus, don't forget, with the lone pair, and the curly arrow that goes from the lone pair to the carbon with the positive charge on it. There you are for your mechanism. You've got 1 mark for these curly arrows, 1 mark for the correct deltas, and another mark for this intermediate and the Br minus with the correct curly arrow. To finish your mechanism, you need to put in just what your final product is. So down here we have CH3, CHBr, CH2, CH2, Cl. And again, you've got the structure of the molecule shown either in your mechanism or from your equation, which will give you a mark there. The final mark again is to say that these are both heterolytic fission. So here we've got that the bond is broken by heterolytic fission. So if you put all that in, you will get a full 12 marks. That's a beautiful question, 12 marks here. So let's just take a look back at where we will pick up all these different marks. So first of all, we've got 1 mark for that equation. So you're going to give me a red pen. 1 mark for that equation. You've got 1 mark for showing the structure of the product. I'll give this a tick for the structure of the product there. It could have come from that mark there. You then get 1 mark for showing this Cl minus ion produced in the mechanism, 1 mark for your deltas and 1 mark for your curly arrows there. So 5 marks there. This heterolytic bond fission will get marked if you've got both of them as being heterolytic bond fission. So I'll mark that in a moment. On the following page then, once you've drawn out your molecule correctly, plus your HBr, there's 2 possible products, remember. You've got your Br there and there, so they've been substituted either onto that carbon or on that carbon, the Br. So you get 1 mark just for writing the equation, just one product, remember it's an addition reaction, and 1 mark for saying that you would get a different product as well. And there's also there 1 mark for getting the correct structure, so 3 marks in total for that part. Then further on down, for your mechanism, you're getting a mark for your curly arrows here, for your dipoles, for your carbocation with the Br minus and the curly arrow, and finally you get that final mark for saying both are heterolytic fission. So 12 marks, 2 mechanisms. Learn those mechanisms. This is question 8 of January 2013 F322. This is the last question on the paper. It's worth 10 marks, and what is key for its quality of written communication, notice as a pencil by the answer, you need to link every single piece of information to your conclusions. So, compound X is a saturated compound that contains carbon, hydrogen and oxygen only. You're given some masses, you're given a mass spec, you're given an IR spec, and then it asks you on the following page, using all the information, show the structures of compound X, which is where I'm going to start, and compound Y, which we'll have a look at in a moment, and include an equation for the reaction of compound X with ethanoic acid to make compound Y. So we're going to go right back to the beginning, and we're going to start with the first piece of information it gives us. So first of all, it's saying, if we highlight this piece, this is the information we've got to use. Now, this piece of information you can use now by pausing. This is going to give you your empirical formula. The question tells us we've got carbon, hydrogen and oxygen only, but it's only given us a mass of hydrogen and carbon, but it does tell us, crucially, that we have 1 gram of the sample. No, thank you. So we can start off by doing 1 minus 0.133 minus the mass of carbon as well, 0.6, and that will give us the mass of oxygen. So we can start doing our empirical formula. The mass of oxygen comes out to be 0.267. So putting each of those in columns, we've got carbon, hydrogen and oxygen, mass over mR, so first of all 0.6 over 12, 0.133 over 1, finally the oxygen 0.267 over 60. They come out as 0.05, hydrogen obviously 0.133, and oxygen 0.167. Notice I'm rounding still to 3 significant figures because that's the number of figures that they've given me for the hydrogen there, so I'm using the same number of significant figures. Now, it's important that you show this working because this working is going to be worth a mark. Then we can divide through by the smallest. Just checking which the smallest is. Here we've got the smallest is 0.05. So if we divide, oh no, we haven't. Sorry, I've made a mistake here, haven't I? This oxygen is actually 0.0167. So that's going to be the smallest one. I'm going to divide through by that. So I'm going to have 1 oxygen in the end. Divide by that one. Divide by that one. So I have then 1 oxygen, hydrogens, I have 8, and carbon 3. Again, this is going to give you a mark, but the clearer mark will be for saying that you have the formula C3H8O. And that formula, of course, is your empirical formula, and I suggest you label it as your empirical formula. So that's that section. You've now picked up 2 marks from using that piece of information. You must use that piece of information. You must work out your empirical formula. Then, from there, we know now then that we've got an empirical formula equal to C3H8O. This is where we use our mass spectra. Here we have our peak. It's called, pause, our M+, and it is on this spectra at 60. So it's either the M+ peak at 60, or you can say that the MZ is 60, which means that the molecular formula is equal to 60. So what you need to do now is make it clear to the examiner that you're checking that your empirical formula matches with your molecular formula. So here we've got 3 times 12 plus 8 plus 16, which does in fact equal 60. So the molecule has the molecular formula of C3H8O. We now know that that is our molecular formula because the empirical formula matches the data given on our mass spec of being an M+ peak at 60, our MZ value being 60, and therefore our MR being 60. So we've now used the mass spectra as well. If we go on now, we move that out of the way. we look at our IR spectra, another piece of information, more marks to pick up. Here we can see that our key absorption is in the region between, on your data sheet it says 355 and 33, I think it is, there. And we've got our key absorption there, which is the OH group of an alcohol. There's no peak here to indicate a C double bond O that you could have. This peak here is representative of, pause for a moment, of your CH peak, so that's your CH. There's no need to comment about that, you can ignore that completely. This is the key peak, this is our OH peak, but we've got to make sure that we say absorption at 355 to 3, I can't remember, is it, what's it say on the data sheet? 320, isn't it? 3200 centimeters to the -1, indicating an OH, and importantly of an alcohol, which means, and state that means, therefore compound X or molecule X must be an alcohol. So that's your next marking point. Then if we continue on from there, we can say that we know we've got our molecular formula C3H8O, and it's going to be an alcohol. So what you need to do at this point is not just decide, oh, it's going to be this structure or that structure. Have a look for isomers. So we've got a possible isomer of C, 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 OH, and I'm going to put my hydrogens on, because if you don't, you will not get a mark. This mark scheme will accept any unambiguous structure, so structural formula, displayed formula, or skeletal formula. It doesn't matter which you use as long as it's clear to the examiner. So there I've got propan 1-ol. Here in the question it has not asked you to name them. So you do not need to name them, you just need to show the structure. That's one possible structure at this point that I've got. The next possible structure is an isomer of this one. Rather than being a primary alcohol, you have here a secondary alcohol, and there you have it. Now, key mark that most people don't pick up on this question, remember this question is 10 marks, 10% of your grade, difference perhaps between one grade boundary and another. What people often don't pick up on is how you decide which one of these is your molecule. So, moving back to have a look at our mass spec, because this is again a key marking point. You must identify this huge fragment here. What will that fragment be? It's at 31, so it's got an MZ of 31. What will it be? You go back down to the molecules, What could have a fragment of 31? Cut it up and see. We've got here in this molecule, fragment here, 15. Same, we're going to have a fragment here of 15. This one, in the difference with the OH here, 2 carbons, so 24, plus 16, it's a 40, 41, 42, 43, 45, 46. Not a fragment of 46. This one, here we've got a fragment of 12, plus 16, so 28, 29, 30, 31. So my fragment at 31 is going to be a CH2OH. And to get the mark, please, 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 just do this little extra bit of activity. Put that plus on, don't forget it. That will give you a mark for identifying the fragment. It's at 31. That's the MZ to make it all proper. MZ fragment 31 is that, which means, and you can conclude, which means, therefore, X equals, and you can identify that molecule. I'm going to draw the structure rather than write the name because it's going to give me the mark for the structure in this mark scheme and not the name. Look carefully in the question. If it's asking you to name it, then do name it. If it doesn't ask you to name it, you don't have to name it. Be watchful, because if you name it incorrectly, sometimes they give you a contradiction and don't give you the mark. So there we've got that X is equal to propan 1-ol, my structure there. At this point then, I can move on to the next part of the question. Just to review, I have used every piece of information on this page. I've used the masses to work out my empirical formula. I've taken the MR from my mass spec and I've looked at one of the fragments and identified it. I've then gone and identified the functional group from my infrared and made sure I've quoted the wave number and the bond, and then concluded that definitely X is an alcohol. I then went to identify my isomers, which is key. This is often the part that people miss out. Identifying which possible molecules there could be at this point, using the fragment then to identify specifically which X would be. So on to the next part of the question. This then is to identify compound Y. We know that X reacts with ethanoic acid in the presence of a concentrated sulfuric acid catalyst to make Y, and it's given us the molecular formula of Y. So what I can do now is say that, and I have to state, because it's got this pencil here, this pencil, quality of written communication, is here, wants you to state the obvious. It just wants you to say that Y must be what type of molecule. It just wants you to tell the examiner what this molecule is. So pause, what is it? It must be an ester because it forms from the reaction of an alcohol go away, of an alcohol, I'm sure you're clear with that, with, and the key word here is carboxylic acid. In this mark scheme, it wasn't good enough to say react with ethanoic acid because it mentioned it in the question. It wanted you to know that ethanoic acid was a carboxylic acid and that an ester forms when an alcohol and a carboxylic acid react. So that was a key marking point that you had to state, and people often don't state explicitly enough in these questions. Y must be an ester. It forms from the reaction of an alcohol with carboxylic acid. So now it's asking me to actually show the structure of compound Y and write an equation. So I want to actually specifically identify compound Y. So I must draw out, and I'm going to do this using the equation as well. So we've got our alcohol, which is a primary alcohol. It reacts with our ethanoic acid. I'm going to save drawing my hydrogens. There they go. Do put them on. Don't forget a single one, because otherwise you lose a mark. And that gives you your ester. My hydrogen's on again. There we go. Now, often in esterifications, there's this little molecule they forget. It's called a condensation reaction because you also get that molecule of H2O. That is a 2, promise. Then, so, just remember, it's the H from the alcohol and the OH from the carboxylic acid that have been removed to form your water, and you've got your ester. Importantly, write, so you don't have to draw it out again, write compound Y. So that is your compound Y. And that then has got you 10 marks. You get 1 mark for that equation with the water, the correct structure of your ethanoic acid. Make sure it is the structure. Don't just write it out as in the molecular formula. Your alcohol forming compound Y. So 1 mark for identifying compound Y. 1 mark, again, you don't need to name it. 1 mark for the water. By the by, how would you name this? So you've got, you name the alcohol part first, so that's propyl, and then the ethanoic acid part is ethanoate. So you've got propyl ethanoate would be the name of this. You didn't have to name it in this question. You've stated that Y must be an ester because it forms from the reaction of a carboxylic acid and an alcohol. And you've used each piece of information from here. You've worked out your empirical formula. You've used your mass spec for 2 marks. You've got your absorption, and you've got your isomers in your fragment, so that you've identified X as well. So all that together gives you your 10 marks.